Something extraordinary is happening on Saturn's icy moon Enceladus. Scientists have just found powerful evidence that its hidden ocean might be stable and could support life. Using data from NASA's Cassini spacecraft, researchers discovered unexpected heat flowing from the moon's north pole, proving it's active across its entire surface. This breakthrough could redefine where life might exist in our solar system and change how we explore it forever. Section 1. The hidden heat beneath the ice. For years, scientists believed that Saturn's icy moon Enceladus was active only at its south pole, where massive geysers of water vapor and ice shoot into space. But a new international study led by Oxford University has turned that idea upside down. Using data from NASA's Cassini spacecraft, researchers found something no one expected: heat is escaping from Enceladus's north pole too. That means the moon isn't just active at one end, it's active across the globe. Here's how they figured it out. Cassini's Composite Infrared Spectrometer, CRS, collected thermal data from Enceladus's north pole in 2005 during winter and 2015 in summer. Scientists modeled how cold the region should be if it were completely inactive, roughly minus 230 degrees Celsius. But the actual readings were about 7 Kelvin warmer than predicted. That might sound tiny, but in planetary science, that's huge. It means heat is moving upward through the ice, heat that must be coming from below. The numbers are fascinating. Researchers measured a heat flux of about 46 milliwatts per square meter. To put that in perspective, it's about 2/3 of Earth's continental heat flow. When combined with the heat escaping from the South Pole, the moon's total output reaches 54 gigawatts, roughly equal to the tidal energy generated by Saturn's gravitational pull on Enceladus. 2. A stable ocean and the promise of life. So what makes this discovery such a breakthrough? It's not just that Enceladus has an ocean. We've known that since Cassini first detected water plumes. The real revelation is that this ocean seems stable, balanced between heating and cooling in a way that could sustain life for an extremely long time. In astrobiology, that kind of stability is everything. Here's why. Liquid water, chemical nutrients, and energy are the three pillars of habitability. Cassini already confirmed the first two. The spacecraft flew through Enceladus's icy plumes and detected salts, ammonia, molecular hydrogen, organic compounds, and even phosphorus, a key ingredient for biological molecules like DNA. But the missing piece was time. Could this ocean stay liquid long enough for life to take hold? The new research finally answers that yes, it probably can. The study found that Enceladus loses about 35 gigawatts of heat through its ice shell, while the total global heat loss reaches 54 gigawatts, almost identical to the tidal heat input from Saturn's gravitational flexing. This near-perfect thermal balance means the ocean isn't short-lived. It's likely been liquid for hundreds of millions of years. The researchers also estimated the ice thickness at the North Pole to be 20 to 23 kilometers, with a global average of 25 to 28 kilometers. That's thick enough to shield the ocean from freezing, yet thin enough for heat and chemicals to move between layers. Beneath that crust, tidal forces continually stretch and compress the moon, keeping it warm from the inside out. 3. What comes next for exploration? Now that we know Enceladus's ocean is not only real but stable, the next big question is obvious: what's next? How do we find out if something is truly living beneath that icy crust? This discovery doesn't just excite scientists, it reshapes how space agencies plan their next missions. The new thermal data offers critical clues. Knowing the ice thickness 20 to 23 kilometers at the North Pole, 25 to 28 kilometers globally, tells engineers how difficult it will be to reach the ocean. It also identifies the best landing sites for future probes. Both poles now appear active, not just the south. That means new missions could target multiple regions to compare chemistry, heat flow, and surface composition. Future concepts are already being discussed. NASA's proposed Enceladus orbolander would orbit the moon first, then descend to its surface to analyze samples directly. Another concept, the Enceladus Life Finder, would fly through the plumes again, but this time equipped with next-generation instruments designed to detect amino acids, complex hydrocarbons, and other biosignatures. The study's findings will guide these missions by narrowing down where to search and what to look for. Scientists now know the moon's heat balance is stable, So any signs of life detected won't just be flukes of temporary activity, they could represent a thriving, long-term ecosystem. Thanks for sticking with this deep dive into one of the most exciting finds in planetary science in recent years. The discovery that Enceladus isn't just an odd, icy moon with plumes, but might host a stable, long-lived ocean beneath its crust changes everything. It boosts the likelihood of habitable conditions, refines mission design requirements, and points the spotlight straight at this little moon around Saturn. If you enjoyed this video, don't forget to like, share, and subscribe for more updates. And don't forget to leave a comment below. Thank you for watching, and see you next time.